So now that we've had a minute to talk about the different systems inside of an animal's body, let's take a look at the overall body plan, the general structure of an animal. Now, there are many different ways that you can structure an animal, obviously. A fish looks much different than a frog, which looks much different than a bird. But biologists, to make things simple, have categorized them into three major groups based on their symmetry. And to help illustrate this symmetry, because they have such simple body plans, I am going to use Pokemon. Let's take a look at this first form of symmetry. This is bilateral symmetry, and as you can see, I have a Diglett here, a ground type Pokemon that has a line drawn down the center of it. Now, excuse me. Bilateral symmetry essentially means that there are equal left and right sides. And if you look here, down this line, the Diglett looks exactly the same on the left as it does on the right. If you don't account for the little shine on his nose there, ignore that. This is bilateral symmetry. Bilateral, if you break it down, bi means two and lateral means sides. Two-sided symmetry. But that's just the first one. If we look at a Staryu and Starmie, we will see radial symmetry. The best way to describe radial symmetry is to think about a center point. I'll draw it on this Staryu right here. And all of the points on the animal will radiate out from that center. If you see the arrows that I'm drawing right here, let's move these to actual lines so you can see what I'm talking about. So we've got our center right there, and radiating out in each direction are the points of the animal. This is obviously how starfish are organized. That's what these Pokemon are modeled after. But there are other animals that exhibit this as well. Sand dollars, jellyfish, many other creatures have this radial symmetry in which the points come out from the center. And then finally, our last form of symmetry is asymmetry. So when something isn't symmetrical at all, when the points don't radiate out and there's no equal left and right side. And you may be saying, Mr. Cruz, that doesn't make any sense. Why do you have a Poliwag up here? They clearly have an equal left and right side. If we ignore the tail being on one side, you could say if it stuck its tail straight out, you could probably draw a line straight through it, right? Well, here's the crazy thing. This Poliwag has a spiral on it. And spirals are never symmetrical. They don't have these equal sides on the left and right. There's the end of the spiral there, and the beginning of it starts on the other side. And they also don't radiate out equally. There's more layers over here than there are over here to the spiral. So what we've got is something that is asymmetrical. And if you look in real life, you'll see these kinds of things all the time in snails and shellfish. All mollusks, in fact, every kind of gastropod has... not all mollusks, every kind of gastropod specifically exhibits asymmetry. This is also big in sea sponges and coral, who have a sort of amorphous body shape. So then finally, we need to talk about the proper terminology we use to discuss the different positions that a structure can be in on a body. And to help with that, I have this Magikarp here. So this is pretty easy to understand. There's only 4 words to know. One of them you know already, and that's your posterior. But opposite to that is your anterior. So posterior means back, anterior means front. Your dorsal, like a dorsal fin, is at the top, and your ventral is at the bottom. So that is our general way to describe animal body plans.